besides the first one was brown, black, orange. The second one is brown, black, red, and that's 1000 kilo ohm. And then the third resistor has, I think, blue, green, and brown bands, starting on the edge closer to the one end of the resistor. That's a blue and green. Sometimes I mix colors up too. It's 560 ohm. That's the value represented by those three colors. I don't know if blue is first or green is first. Sometimes it's hard to see. I usually, at my age, I keep a magnifying lens with me, and then looking at
This one's green blue.
green, blue. Okay, green is 5, blue is 6. That's the values of those colors equate. And brown means how many zeros you put after the first two digits. Brown means put 1 0. So it's digit 5, digit 6, and then add 1 0, which is indicated by the brown color. Third band is always the multiplier of the number of zeros after the first two digits. But it's fun. You can find smartphone apps for resistor color code, or a program for your computer, and many websites that show color code with animation and fun stuff. The other component that we are going to use is a capacitor. At this stage, the main thing to know about the capacitor is that it blocks direct current or DC and only allows alternating current or AC to flow, and that's needed in certain situations. In our case, it's needed to connect the speaker, which is the tiny round black device with 2 legs in your kit. I don't know if you can see that. It's yeah, that one. This is a speaker that produces sound, and it's based on the third basic component. We saw resistor. This is capacitor. Third component is an inductor. These three are the basic components for building all kind of complex electrical circuits. The speaker that you're looking at, the tiny round black cylindrical thing that produces sound, basically is based on this inductor. Has a coil or a loop of wire inside. That's all there is inside. And the other thing attached to the loop of wire is a metal plate. So when the current flowing through the loop of wire is varied, it causes the metal plate to vibrate, and that's how sound is produced. So a speaker is basically an inductor that produces sound. Inductors can be used in many other ways. This inductor is in your car door lock. So when you press the remote, key button on your car remote, the doors get unlocked, and they are unlocked by having these inductors pull a plunger, that physical lock that is pulled to unlock the doors. In that situation, we call these inductors an electromagnet, because when electricity flows through the wire, it creates a magnetic field around this inductor. And it's the same principle that the speaker works on to cause the metal plate to vibrate. So each of these has certain properties. There are do's and don'ts of connecting these three basic components together, which can be subject of another workshop, or as I said, it can be a lengthy discussion depending on how detailed we want to go into this topic. But for now, actually, this was supposed to be the last slide, so let me go back and so what we want to do is get going with some actual programming and connect things. So if you have your Arduino IDE, you can launch that. As I said in the beginning, we'll only be able to do some basic things to get you interested, and then we can. We are planning on having more workshops, and you can also learn. As I said, if you go to the Arduino website, there are a lot of projects. After you have a basic introduction, you can understand many things and many examples on that website. You can try. Anybody here have their own Arduino board, or have one? Okay. So once you go into the programming environment, assuming everybody has it up and running. If not, I guess you can share your partner's laptop for the time being, and then we can see if it's not working on your computer. But this is if you are running one of the newer versions, which I recommend that you should use the latest version. if you've installed it recently, it should be the latest version, because they are making constant improvements, and many things in the newer versions are much easier than it used to be in the past. So a few things to know here. In the file menu, there are these examples that cover a wide range of topics. And so we'll come back to this. The other things are these buttons. Once you have a program open, let's say we go to examples, and the very first program, which is, when you start programming, typically in a computer science programming class, it's been a tradition that the very first program you write, prints hello world on the screen. So in an Arduino project, there's no screen. You can attach screens these days. I'm working on a project that connects a LCD, color LCD touch panel to Arduino, and there's a project that I'm working on currently. So you can attach screens to Arduino in more advanced projects, but by default there's nothing attached to Arduino directly. So the equivalent of the hello world to produce some kind of output is to blink an LED. So for that reason, almost every introduction to Arduino starts with this blink program. I think I clicked on the wrong one. So once it's in basics and blink, and many people usually have tried this if they have their own Arduino, and so it might not be very interesting for them. But what this program does is, which is it actually, most examples that come with Arduino tell you how the program is supposed to work and what kind of things you're expected to connect to which pin. So, for example, it says here, increase the font size. So, in the comments, it says most Arduinos have an onboard LED, which is one of the 4 LEDs that is on this Nano also. The 4 LEDs are one LED to show transmit, 2 LEDs to show transmit and receive activity when the Arduino is communicating. One LED is for power, and the 4th LED is connected to this pin 13 that's mentioned here. So this program just turns that pin 13 LED on and off, a very basic way of producing an output and controlling an output device, which is the LED in this case. So it's besides like a hello world equivalent, the other benefit of this program is that it tests your basic setup that it's working. That if you are able to get the LED to blink, that means your connection from your Arduino to the PC, the USB connection is good. Your programming setup on the PC is working, and program is being compiled, is being uploaded. So just running the blink program tests the that your basic setup is correct. So it can be used as a test program. When you have a complex project and it's not working, and you're not sure where the problem is, because typically the problem will be either in your wiring and physical connections, or it will be in your program. Syntax errors are caught when you compile your program, but logical errors are not caught. It's programmer's responsibility. So many times you'll run into some logical problem in your program that will keep it from doing what it's supposed to do. So this, going back to this blink always gives you kind of an assurance that if your project is not working, your basic setup is still good. So we'll try this, as it says here, that there's nothing that's needed to connect to Arduino for this part. So if you have the board plugged in, and actually, either way, if you have installed the board, the Arduino Nano into the shield, just make sure the pins are lined up and press it in gently.
I'm just a little bit I can't press it in gently.
Okay. Yeah, sometimes.
I had a similar problem. I think if it goes in far, there's a, it can go in far enough.
Yeah, the first thing is to make sure before you insert that the pins are straight. None of the pins, so that's fine in this case. And since I've been doing this for 10 plus years, I have a feel for how much pressure is needed. So, yeah, that comes with a little bit of practice.
Similar to USB, honestly, I'm afraid I'm gonna break it.
Yeah, this is, as I said, you have to be gentle with it.
It doesn't go in very easy.
I'll try that too.
Do you have USB.
Yeah.